solve a squared minus 2a all to the 1/3 power equals 2 times the quantity a plus 3 raised to the 1/3 power. We know that raising something to the 1/3 power is the same as taking a cube root, so we can rewrite this equation as the cube root of a squared minus 2a equals 2 times the cube root of a plus 3. Now, in solving this equation, we need to get rid of these cube roots, and we can do that by cubing both sides of the equation. On the left-hand side, when we cube the cube root, that gets rid of the radical, and we're left with a squared minus 2a. On the right, we need to cube both the 2 and the cube root of a plus 3. When we take 2 and cube it, 2 cubed is 8, so we're going to have an 8 out front. And then when we cube the cube root, that gets rid of the radical, and then we're left with a plus 3. So we need to multiply that 8 times the a plus 3. So when we do that, that gives us 8a plus 24. So this equation becomes a squared minus 2a equals 8a plus 24. Again, this is a quadratic equation, a polynomial equation. So to solve this, we need to move all the terms to the same side so that the other side is 0. And then we factor the polynomial and use the zero factor property to solve. I want to move everything to the left-hand side because I want to keep this a squared positive, so I want to keep it where it is. To do that, I'm going to subtract 8a on both sides and also subtract 24 on both sides. That leaves us with 0 on the right-hand side. And then on the left-hand side, we have a squared. Negative 2a minus 8a is going to give us negative 10a. And then we also have that negative 24. And now we can factor this by unfoiling. We need two numbers that will have a product of negative 24 and a sum of negative 10. Those numbers are negative 12 and positive 2. So this becomes a minus 12 times a plus 2 equals 0. And once we've factored the polynomial, we can use the zero factor property and set each of those factors equal to 0. So a minus 12 equals 0, or a plus 2 equals 0. And we can solve these equations to find the solutions to the original equation. If we add 12 to both sides with the first one, this gives us a equals 12. And if we subtract 2 from both sides of the second equation, this gives us a equals negative 2. And because we cubed both sides of the equation instead of squaring them, we don't have to worry about the possibility of introducing extraneous solutions. So we can be confident that both of these are actual solutions. And so our final answer is a equals 12 or a equals negative 2. You can always check these in the original equation if you like, but it's only a requirement when we are squaring both sides. When we're cubing both sides or raising both sides to an odd power, there's not the possibility of introducing extraneous solutions.